In 2020 I was introduced to No Man's Sky. The ambience the game achieves makes the loneliness of space travel somewhat beautiful, though you're never quite alone and always in the company of your shoulder-mounted companion. As such, I wanted to develop a desktop version of this robot, and to do so the first problem I needed to solve was to understand the motion of the device. If we study the scanner, we can see that this is a 4-link robot comprising of revolute joints. Moreover, the movements of the robot are deterministic and follow a continuous cycle. This means that the motion of the robot can be described as a simple state machine. We can convert the state machine to code later on. Our robot will be driven by servo motors similar to this one, so we will CAD our entire mechanical structure of the robot around this motor. I'm using Onshape as our CAD software, and I modeled the motor first to use it as a guidance tool to develop the rest of the robot. So I start off with developing link 1, which will sit directly on top of motor 1 and be attached to it through a simple screw. It will also house the second motor, which controls the turning of the eye of the scanner, and inside the eye there's 2 other motors that control the blinking motion. As I mentioned before, we're using servo motors to drive the robot. We're using a Raspberry Pi Pico as the computer of our system. Though the Pico can control the servo motors, it cannot deliver enough current to them. Instead, we want to power the entire system through a laptop charger. But first we need to create our custom PCB that will accept the laptop charger and distribute this power to all the servo motors and the Pico. I am using JLC PCB to manufacture the PCB. This company stores many electrical components which they can solder onto the board themselves. I'm using Easy EDA to design the PCB. I first connect a DC jack barrel to a switch. This mechanism turns on and off the entire board. I then insert 2 female headers in which the Raspberry Pi will connect onto. Thereafter we move on to creating our voltage regulator circuits. These components drop down the high voltage of the laptop charger so that it's suitable for use with the servo motors and the Pico. In the end we have something like the following: a bunch of voltage regulator circuits which are pulled up to the voltage of our laptop charger by our switch mechanism. These voltage regulators drop down the voltage to a suitable 5 volts for the Pico as well as all the other servo motors. The schematic is then converted to a PCB layout. Here we can see the overall shape of the board and the routing between all components. Easy EDA also allows us to view how the real board will look like. And after JLC PCB manufactured these boards, I was happy with how they turned out. Furthermore, the same process was carried out to create the eye of the robot, which is simply a number of LEDs which are connected in parallel.
Radiation protection falling.
To make decorative pieces which have a more curvy and organic shape, we can first export our Onshape CADed designs into Blender to use as a guide. We can then model around this. As you can see here, we have made the top cover of the robot. What you're seeing here is a mesh of the PCB that I showed you earlier, only this time with a switch soldered onto it. So the way this was made was through a process called photogrammetry, which I took many pictures of this PCB with my phone and used the software Meshroom in order to create this mesh. Now the reason that I did this was to use it as a guide to develop the overall PCB cover for the robot. To control the servo motors, the Pico needs to be able to generate PWM signals. Now to achieve this, I'm using the code provided by Kleist Robotics, and he's a YouTuber and his details will be provided in the description. At the beginning of the video I showed you the state machine that we wanted to map to code. This is being done here in the implementation of a switch statement in many cases. Each of these cases represent a state of the base link. In the end, after soldering all the wires and assembling all the components, we are left with the following. All the 3D printed components were made at a local company called Phaser 3D, and I'm happy with how all the 3D prints came out. However, unfortunately the weight of the robot makes it seem quite flimsy. I believe next time I'll choose larger and more powerful servo motors to prevent this. Another mishap that I encountered was that I accidentally damaged the first motor during assembly, so this is the reason that the first link doesn't move. Regardless, I learned a lot of skills during this project, which I'm looking forward to taking into future projects. And with that, I'd just like to thank you for watching, and I hope you found something interesting in this video. Take care.